Hello my dear class 10 students, how are you all? I hope you are doing amazing. This is your Ekta ma'am here. This is one of the most requested question and video from my students. What they want to know, electrolytic refining versus electrolytic reduction. Yes my dear students, this is one of the most confusing and most scoring part of your chemistry portion from your science book. Yes my dear students, do not worry, we will cover it all in this one video and you will not have to worry about it anymore. So let's start. Electrolytic reduction. Now before we talk about electrolytic reduction or electrolytic refining, you should know one thing. There is a metal reactivity series. Now what is that series? This series tells the reactivity of the metal. Depending on the metal position in this particular series, we can predict whether they are more reactive, less reactive, moderately reactive, not reactive at all. Okay. So all these things are told by this single reactivity series. So in this series, we start with potassium, sodium, calcium, magnesium, aluminum. These are the metals of highest reactivity. They are really high reactive metals. Okay. And then we go to zinc, iron, lead. They are the metals of moderate reactivity. And then we have copper, mercury, silver. They are the metals of low reactivity. They are medium reactive. Then we have low reactive metals. And then in the last, gold, platinum, they comes under the least reactive, or you can say non-reactive category. Now why does it matter, ma'am, which metal is lying at what position? Because depending on this position, it is going to tell which metal will undergo electrolytic reduction and which metal will undergo electrolytic refining. Now how? Now these metals you can see from potassium to aluminum, they are the metals of high reactivity. These metals will undergo electrolytic reduction. These metals will undergo electrolytic reduction. Okay. Now these metals of moderate reactivity and metals of low reactivity, zinc, copper, iron. Now these metals will undergo electrolytic refining. Yes, so always remember it. Metals of high reactivity will undergo electrolytic reduction and metals of moderate to low reactivity will undergo electrolytic refining. Now what are these processes? Let's discuss them in detail. Electrolytic reduction. So electrolytic reduction is shown by metals which are highly reactive. For example, sodium, potassium, aluminum, calcium, right? These are the metals of high reactivity. So electrolytic reduction is shown by these kind of metals. Now what exactly is electrolytic reduction? You are extracting metal. This is a metal extraction method. This is a metal extraction method. This is a metal extraction method. Yes, this is a method of extracting metals, right, from their molten compounds. Usually what kind of compound we have? We have molten chlorides. We have molten chlorides and we separate them out using electricity. We extract the metal using electricity. Now see, you have ore, right? Then what do? You do concentration of ore. That means you remove the unwanted impurities. After you do the concentration, you have the ore. You have the ore only, right? And that ore is, let's say, chloride. That ore is, let's say, chloride ore. Now what do? First step, you heat that. You heat that chloride ore until it melts. Until it melts, because only when it is melted there will be free ions to conduct electricity, because we are passing electricity, right? So to conduct electricity we need either ions or electrons, and in here, since it is solid, we are not having either of those. So what we will do, we will take the chloride and we will melt it. We will melt it, and after melting, what will happen? We will have free ions. We will have these free ions, right? Now what will happen? Then you pass the electricity. Firstly you melt it, then you pass the electricity. If you pass the electricity, now there are ions. Now there are ions. If you have melted sodium chloride, what ions we have? We have Na positive ion and we have Cl negative ion. These ions will have, and these ions will conduct electricity. These ions will conduct electricity. When electricity is passed, then again through this molten liquid, we have two electrodes also. What are these electrodes? These electrodes are inert electrode. These electrodes are inert electrode. Normally we take graphite electrode. Graphite, you know what is? It is an allotrope of carbon. We take graphite electrode. Both are made up of same material. Okay. You have melted it. You have passed electricity through it, right? Now what will happen? There are two. One is anode and one is cathode. There are two electrodes. One is anode, one is cathode. Now, what is anode? Anode is actually the positive electrode. Anode is positive electrode, right? Now you know if an electrode is positive, if anything is positive, negative will come and attract, right? Negative, it will attract what? Negative ions. Since anode is positive, it will attract negative ion. What is the negative ion here? Cl negative. Anode negative ion is Cl negative. Negative ion is Cl negative, right? And cathode, what is cathode? Cathode is a negative electrode. Cathode is a negative electrode. Cathode is a negative electrode. So what kind of species will come to it? Positive species will come to it, right? So that means Na positive is positive, right? So it will go to the negative electrode, which means to the cathode. And Cl negative, which is a negative ion, it will go to the positive electrode, negative positive, right? So positive is the anode. So Cl negative will go to the anode, Na positive will go to the cathode. I hope it is clear now why anode and cathode. Again, I'll repeat it for you. Anode is negative. Sorry, anode is positive. What happens at positive? Negative will come. Cl negative will come to the anode. At cathode, cathode is negative. So positive ion will come to it. And what is positive here? Na positive. What is positive here? Na positive. So Na positive will go to the cathode, Cl negative will go to the anode. This is what is happening here. Cl negative is going to the anode and Na positive is going to the cathode. Okay. Now what is happening? Again, this is the simple process at the cathode. At the cathode, two type of reactions are happening. Let me write it for you. Cl negative is losing electron. Cl negative is losing electron. And is getting converted into Cl. Na positive is gaining this electron, is accepting this electron and getting converted into Na. Now this process is happening at anode. This Cl process is happening at anode and the sodium process is happening at cathode. This process is happening at cathode. I hope it is clear now. The negative ion chlorine is going to the anode and the positive ion Na positive sodium, it is going to the cathode. Clear? That was electrolytic reduction. We use it to extract metals of high reactivity like sodium, potassium, aluminum, calcium, right? Then we have electrolytic refining. What is electrolytic refining? So electrolytic refining, that means it is a purification method. This is a purification method. And what are we purifying? Again, I told you in the beginning only, we are purifying metals of moderate reactivity to metals of low reactivity. Metals of moderate reactivity to metals of low reactivity. Zinc, copper, right? These kind of metals we are purifying. That means we already have extracted them. That means we already have extracted them from their ores. What we are doing, we are just cleaning, polishing them, like, right? You have already taken it out from the ore. Now you have the metal, but you want to purify it because it still has some impurities, right? So what is that? That is electrolytic refining, right? In electrolytic refining, again, two rods are there, but in that one the electrodes were graphite, inert electrodes. Graphite were there, right? Here, what do you have? You have impure metal rod and you have a pure metal rod. Let's say I'm trying to refine copper. So what do I have? Impure metal rod, which is impure copper metal rod as the anode and the pure copper metal rod as the cathode, right? Anode as the impure metal rod, cathode as the pure metal rod. Again, the solution, this is the electrolyte. What is the electrolyte? It is a soluble salt solution or aqueous salt solution of that metal. It is not a different one, okay? So whatever metal you are trying to refine, you make that impure metal as the anode, the pure metal as the cathode, and the electrolyte is the solution of, an aqueous solution of that metal, So here if we are trying to refine copper, so this solution will be of aqueous copper sulfate. This solution will be of aqueous copper sulfate. Now what is happening when you pass electricity? So when you pass electricity, this anode will start breaking down, and it will dissolve in this salt solution. From the salt solution, an equal amount of copper will deposit on the cathode. So what is happening with time? If you pass the electricity, this anode will break down, and every and your metal will deposit in the salt solution. From the salt solution, an equal amount of metal, copper metal, we are talking about copper metal, equal amount of metal will deposit on the pure metal. So normally we take this one thick because we want to purify it, and then we take this thin strip. What happens at the end of the reaction, when you have passed electricity for enough time, this is vanished, this has vanished, there is no anode. There is no anode. This all has dissolved in the salt solution. From the salt solution, equal amount has deposited on this plate. So this is thin. At the end, this is very thick, this is very thick, like this thick, and this is vanished. There is no anode. There is no anode, right? And that's how you purify metals of moderate reactivity to metals of low reactivity, right? So this is again, this is the only process written here. You can refer to it because it is systematic process of what is happening in these 6 steps only. At anode we have the impure metal rod, at cathode we have the pure metal rod. When you pass the electricity, anode breaks down and equal amount of salt from the salt solution, from the aqueous salt solution deposit on the cathode. At cathode you will be getting the pure metal, at anode the impure metal rod is getting disintegrated, right? Now one more thing is there, this thing. This is called anode mud because all the impurities are getting deposited right under the anode. That's why it is called the anode mud. Now let's distinguish them. A basic distinguish, okay, differences: electrolytic refining and electrolytic reduction. So this is used for purifying an impure metal using electricity. One thing is common, we are using electricity in both cases, but in one case we are just refining an impure metal, purifying an impure metal, while in electrolytic reduction we are extracting a metal from its molten compound. We melted it first, right, because there were no ions. I hope it is clear now. Then it is done to remove the impurities, and this is done to obtain the metal. See the difference. We have the metal in case of electrolytic refining. We already have it, but it has some impurities and we want to remove those impurities. But in electrolytic reduction, we do not have the metal. What we have is an ore, and we are trying to extract the metal from that particular ore. Next, it is used for less reactive metals and it is used for highly reactive metals. Impure metal rod is acting as the anode, and the inert electrode, usually we have graphite, is acting as the anode. In case of cathode, pure metal sheet is taken as the cathode. Here also again metal is deposited at the cathode, and what are we taking as the cathode? Again inert electrode. Inert electrode is taken as the cathode. Aqueous solution, electrolyte. What is the electrolyte? That's a salt solution we have. In case of electrolytic refining, the aqueous solution of that metal that we need to extract, that we need to purify, the salt solution of that metal that we need to purify is taken as the electrolyte. And for electrolytic reduction we have the molten compound, molten ore, right? Pure metal is obtained at the cathode. Again, in both cases, in one case we are getting pure metal and in this case we are getting metal. After this you will refine it. After extracting the metal using electrolytic reduction, then you will refine it, right? And last, there is anode mud. In this case there is no anode mud because we are extracting metal here and from the ore, and in electrolytic refining we are removing the impurities. So impurities will be there as the anode mud. And that was all. I hope it cleared all your doubts. If you have any other doubts in chemistry portion, do let me know in the comment section, and all the best for your exams.